All right, Intro to Engineering Design. It is time for the semester exam. And what we're going to do this time is I'm just going to try to briefly go over some of the concepts, and I'm going to make this the study guide. I'm going to share this document as well with us too so that you can actually have it available to you. But I'm just going to go over the main concepts that we've done for the entire year and everything that you might have a question on the exam coming later on this week. If you're looking at this and you're not actually in my class, if your teacher has given you nothing and they're just kind of like, well, it's 2020, have fun, something's better than nothing, you're more than welcome to look over these. But, obviously, this is going to just be specifically for my class. This isn't like a standardized project lead the way thing. The very, very first thing that we've done is we did a couple of projects at the beginning of the year, and it was generally trying to reinforce the concept of the engineering process. So we need to know the concepts behind the engineering process. So I'm going to go ahead and write down engineering process. And what's in the engineering process is step one is you have to define the problem. You have to know what you're actually solving first. This comes to limiting constraints and basically asking the question, what am I actually trying to solve? The next thing after that is you generate concepts. And that normally goes into the category of concept sketches and brainstorming sessions and trying to find out like how you're actually going to solve the problem. So then you got to think about what you're actually going to do to solve this problem that comes into play. The next thing that we're going to do is develop the solution, and this normally involves trying to write out or come up with thoughts and processes of how it actually works. Let's see here. After that, we are constructing and testing. So that's when you actually build it. And remember, in projects, this is what people do the most often. After that is evaluating the solution. And if we have time in class, normally what we do is we present the solution afterwards. So evaluating is a personal thing. You're actually looking at the solution and seeing if there's anything that you needed to change around on it. Presenting the solution is you're confident enough that you've got everything done and you're going to present it to some kind of audience, usually the people who are wanting the problem solved. Let's see here. The next thing that we needed to remember is engineering notebooks. So there are some rules for engineering notebooks that we went over at the beginning of the year. The big things that we need to really think about is there's no blank space allowed in an engineering notebook. Make sure that it's always in pen. And let's see here. Keep in mind, remember that it's legal documentation. So it's not okay to have things like, loose pieces of paper or writing in pencil. Anything that can like leave the notebook randomly, you really don't want to do that as a good practice for making an engineering notebook. An engineering notebook is where we put all of our stuff. So just in general, keep those rules in mind. You may have to go back over the lesson that deals with engineering notebooks, and you can find that in the Project Lead the Way stuff towards the beginning of the sections. So Unit 1 would be for us. Let's see here. A couple of other things that we did was we did the difference between innovation and iteration. So if you're taking, and also iteration, innovation, and let's add one more. I'm going to do a terrible English teacher thing. And invention. Please don't tell English teachers that I did that. So innovation, iteration, and invention. So an innovation is taking something and making something a little bit better. So you're taking like an iPhone. It's the difference between an iPhone 4 and an iPhone 5. Ideally, they look roughly the same, but they're going to be better in some way, shape, form, or fashion, or at least different in some way, shape, form, or fashion. Iteration is the process of going back over the design over and over and over again, hopefully to actually improve it. So an iteration is kind of like a go back and do again. Invention is something that's completely new. It's a new product, it's a new service, it's something that nobody had actually thought of, or if they have thought of it, nobody had patented before. So an invention is something that was going to be completely new. Like the original iPhone is a good example of that one. It was a completely new thing. Or whenever people first started doing it, like keyboards and typewriters, that was a completely brand new thing. Let's see here. One of the other things is after we started like messing around with the engineering process, some of the things that we did was we gathered data. Keep in mind that we actually used Google Sheets, which is kind of like Microsoft Excel for spreadsheets, and this is how we actually gathered our data. Let's see here. You need to know the difference between, whoopsie, you need to know the difference between a concept sketch, a multi-view drawing, a dimension drawing, and yeah, that's pretty much it. So there's several different types of drawings that we actually do. So the first one is a concept sketch, and this is what we originally started on. Keep in mind that concept sketches are quick and dirty. They're not actually meant to be super, super detailed. They're not going to look very pretty. And then we've also got things like multi-view drawings. Remember, these have the like top, front, and side view inside of them. So a multi-view drawing is normally not a concept sketch. It's normally much, much more developed. A dimensioned drawing is kind of like a multi-view drawing, but it has dimensions inside of it as well too. So if I talk about a dimensioned drawing, that means that it's actually got some numbers that go along with it too. You also need to keep in mind the difference between isometric versus orthographic. And isometric is where you look at something and the grid looks like triangles. So it gives you a good idea of what a three-dimensional object looks like. Orthographic is your regular plain Jane grid paper. So that's the difference between isometric and orthographic. Let's see here. We did actually use 3D printing in the classroom, so keep in mind that we did use 3D printing, and it was a viable thing. Let's see, next thing inside here is we also learned what constraints were, and constraints were limiting the design process. So, and it wasn't necessarily in a bad way, it was just things that you needed to add on to it to make it actually happen. Okay, we also learned how to take different parts and put them together. So this is where we actually started our 3D modeling stuff. So there was a lot of three-dimensional modeling that we did in Onshape. That was the software that we actually used. Let's see here. We learned to take different parts that we developed and we put them together on each other, and that was creating an assembly, which is a lot of parts that are put together to make one whole thing. Let's see here. You also need to know the notation for radiuses, and usually these apply to holes or fillets. So you need to know the difference between them. Look back on our references between them. Radius is going to look like a capital R, and it's going to be just to the left of the number of itself. And if you're looking for a circle, if it's the diameter of a circle, then it's going to have that line through it. It's going to look like a circle with a line through it. So I'll go ahead and I'll put hole notes here as well too, because you're going to need to know the difference between through hole, let's see, countersink, uh, counter bore, and let's see, there was one more thing that I'm missing off the top of my head. And I guess the diameter. We'll go ahead and just put the diameter in there as well too. That's probably the one that I'm thinking of. Okay, let's see. We also need to know the difference between additive versus subtractive methods. So an additive method is going to be taking something and adding it on there. So like if you have a rectangle and you add another rectangle on top of it, that would be an additive method. If you have a rectangle and you subtract a chunk out of it, or you cut a chunk out of it, that's going to be a subtractive method. That's pretty straightforward. A 3D printer is a good example of additive manufacturing. Most tools like drills, table saws, things like that are usually subtractive. They cut material away from it. There's a crap ton of lines that we need to remember. So let's see here, there's construction lines, and construction lines are those little dashed lines that show oh no, I'm sorry. Construction lines are those little dashed lines, really lightly put in. I normally make them dashed because I have a marker or a pen that I'm working with, so I don't really have the option of making them light, but they're not actually a part of the construction itself. It's just to actually get a good sense before you actually start drawing things in there. There's also hidden lines, which the hidden lines are the dashed lines that indicate there's something behind it. There's object lines, and object lines are the actual edges of the object that you can physically see from that view. Let's see, there's center lines, and the center lines normally represent let's see here. Center lines normally represent the center of a circle that we have. And make sure everything's okay. Yep, there we go. Let's see here. What other kind of lines do we have? I'm trying to think of, um, let's see here. Center lines, object lines, hidden lines, construction lines. I think I'm missing one. Um, if it pops up here, I'll come back to it just in case, but we're just going to kind of keep going down. Let's see here. Center line, object line. Okay, here we go. A three-dimensional object, we know that's called a solid. This is different from the physical science definition. So if you're dealing with a three-dimensional body or geometric figure, that is called a solid. That is not called a volume or anything like that. We call it in engineering, we call it a solid. Okay. Keep in mind we also used to find, really precise measurements, we used a dial caliper. So keep in mind that you're going to need to know how to read a dial caliper and also what those notations are going to be. In 3D design, we used the circular and linear pattern tool. So you need to at least know what it looks like and be able to identify, oh, hey, that's actually done with a circular and linear pattern tool. So keep that in mind. I'll just have a picture of it and you'll be like, hey, this is a linear pattern. Or hey, this is a circular pattern. For those of you who are like, oh my gosh, what's that? A circular pattern goes in a circle. And a linear pattern is the same pattern that goes along in a straight line. Let's see here. You also need to know how to identify what a detail view looks like. And a detail view looks like an individual section that kind of goes, you zoom in on it, there's a circle on it, and then you zoom in. The types of tolerances. So tolerances, there's a limit tolerance, there's a unilateral tolerance, and there's a bilateral tolerance. So a limit tolerance has the two numbers, the upper limit and the lower limit, just written out there. A unilateral tolerance has a plus and a minus, but one of those is 0. And a bilateral tolerance has a plus and a minus, and both of the numbers are not 0. So it would be like plus or minus 5 or plus or minus 2. Unilateral tolerance would be like plus 5 minus 0. And the limit tolerance would be like, somewhere between 30 and 25. That would be the difference between those three different types of tolerances. Let's see here. Moving on. Um, we did use the revolution. This is not like the 1776 revolution. This is the revolution command. We took that to make it go in a circle. Some other things that we used the sweep function. So you need to know what a sweep function generated object looks like visually. The features, let's see here. You need to know the difference between a fillet and a chamfer. A chamfer is going to be kind of chiseled at like an edge, and the fillet's going to be rounded, like you took a bunch of sandpaper and put that onto it. You also need to know that we used the bread and butter, which is the extrude command. We use that a lot. Let's see here. You need to know that the fillet command can be done in sketch mode or 3D modeling mode. Let's see here. The types of mates. So when we got down to the bottom, so there's the revolute mate. There's the fixture, I think is what we called it. And there's the cylinder mate slash slider mate. Usually those are kind of used one part and part of the same. The cylinder mate allows an extra degree of freedom, whereas the slider mate just lets it slide like in and out or up and down or whatever you want to call it. Let's see. Constraints inside Onshape. So you need to keep in mind that there are some constraints. Most notably, the ones that we really used was the vertical, horizontal, and parallel and perpendicular constraint in sketch mode. So I'll have a picture and you'll need to be like, hey, that's a vertical constraint. If it's straight up and down, that's vertical. If it's left and right and flat, that's horizontal. If there are two lines that have the same slope, that is parallel. If there are two lines that are 90 degrees separated from each other and they have a reciprocal slope, so if it's like, +2 and the other one's like -1/2, they're going to look 90 degrees from each other. Don't get too bogged down in the math. That's going to be perpendicular. constraint. So that's the difference that you need to know for those. Let's see here. What type of constraint? There's a couple of these. Blah, 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 blah. All right, and I think with that, that's pretty much everything that is going to be on the semester exam. Oh, there was one more thing. The cross-section view. Keep in mind that a cross-section view is going to look like it's an object that has been literally cut in half, and you're going to be able to see through it like it's been dissected. And I think with that, that's going to be pretty much everything that's on the semester test. So, hey, good luck with it. I hope you guys have a great week, and I hope you all have a great Christmas break, and I will talk at you guys later.